Well, good morning or good afternoon, wherever you're joining us from today. Thanks for making the time to come to our mini-series today. My name is Helen Berkowitz, Senior Marketing Manager here at PractiTest. Today, we are continuing the second part of our three-part mini-series, Deciphering Alerts Make Sense of What Your Software is Saying, led by Lena and Nyström. Before we get started, I just wanted to thank you again for your patience and apologize for any confusion there might have been with the time change. Daylight savings time kind of caused a little bit of a hiccup there, but we're ready to get started. Just a little bit about Lena. Lena has been building software since 1999. After a decade of coding, they found their heart in testing. Although they focus on building organizations and growing people rather than the software itself, today, testing is still very close to their heart. Continuous improvement is a core value, and they believe that we should all strive to keep it up to date, challenge ourselves and our assumptions and the way that things are done. Lena is the author and creator of Would You Risk It, an avid blogger, speaker, and workshop facilitator. In addition, they combine skills learned through their years in their day-to-day job as an engineering manager. For those who might be a little bit unfamiliar with PractiTest, we just wanted to give you a little bit of an insight as to who we are. PractiTest is a technology company offering an end-to-end application lifecycle management solution. It enables our customers to incorporate all testing elements from bug trackers, CI, CDs, and automation frameworks, regardless if it's scripted or exploratory testing, onto one single platform. With that, they get increased visibility, streamlined processes, enhanced efficiency, and as a result, lower costs, less time to market, and improved ROI. PractiTest is an industry leader, well loved by our customers. We work with some of the biggest global brands across all industries, from technology to healthcare, retail, finance, government, and more. We'd like to also invite you to join us next month for one of our live training and QA sessions. You'll be able to learn more about PractiTest and how it can help you solve your challenges. So without further ado, Lena, the floor is yours.
Thank you so much. I just noticed roadblocks in your list of customers, which I thought was really cool as a mom of two, which I would love to hear more about at some point. But let's get started with the mini-series instead. If I can just get all of my screens where I want them so I can see everything. There we go. Thank you for being here again today. This is, as mentioned, the second part out of 3 in a mini-series about deciphering alerts. And today we're gonna, today we're gonna focus on different part of the stack, or actually it should say different part of the technical ecosystem you're in, but we'll get to that later. Extremely short about me. I have a degree in the softer computer sciences called informatics. I did about a decade as a developer, building large insurance systems mostly. I'm very proud to say some of my code is still running today, paying out lots of money, which is one of my biggest achievements still, even though I also wrote that book mentioned. I found testing. Well, I found it earlier, but I took the switch to testing around 2009, 2010 fully. I've been doing that mostly around the concept of how can we make testing and quality better. Since 2017, I've been focusing on people management, building organizations, and also my side career as a speaker, which is incredibly grateful for because it allows me to do things like this. So last week, I gave you an introduction to some perspectives and challenges, making it really hard to write good messages to your users. And today, we're going to look more specifically into different parts of the stacks, some typical different characteristics for them, give a few examples. We're going to talk about frontend, we're going to talk about backend, databases, and the ecosystem in general, because there's also things outside of software that we're building ourselves. And then next week, we're going to look even deeper into some typical error types, how to find clues in messages, and how we can use them to do better testing, basically. So the main message today that I want you to leave with is that messages that originate from different parts of your software have different characteristics. And this is a disclaimer for this entire talk today. This is a generalization. There's also been, of course, a lot of shifts over the years. So what was true 20 years ago is perhaps not as true today. But there's still a lot of differences that we can catch up on. So if we, for example, look at something like an email validation, it could look like, please enter a valid email address in the front end. It could look like, if you've seen the famous $ user email error messages, if it comes from the back end, you can have a unique constraint if it comes to the database, or you can have an SMTP error if it comes from the mail server. These are very clear, but it also shows you how error messages or messages in general can look in different parts of the stack. So when it comes to front end or the interface, some typical characteristics are that they occur real time, or like as close to real time as possible. And they kind of sound like a receptionist. They sound very polite and helpful. They're visual. They're there to stop you from stepping in a puddle. The purpose of front-end validation is mostly user experience. We want to guide our users to not make mistakes, because it will increase the likelihood of them following through on whatever it is they want to do, if they want to buy a dress or book a table at a restaurant. We also use it to sanitize the format of the input, so we don't have to check that, or we don't have to get garbage data in the end. And if we catch that in the front end, we don't have to have a lot of network traffic. That might not be as important today when people have often good network traffic, good like mobile phone data and all of those things. But it's still good to reduce it as much as possible. But it is limited in what it can do. It is limited to a lot of assumptions. So we can't use that as our only protection. We can't trust it to keep the data safe. And also, if we do too much validation in the front end, our users would get annoyed. So here are some typical examples of front-end validation. This is from the Swedish train booking system to the left, where you have these very typical red helper texts. And to the right, we have the Amazon sign-up page, which also, you see, it's kind of the same type of language. It's kind, it's helpful, it's specific, and it's usually very easy to understand what it is they want from us. If we take just one step down in the stack and look at the back end of the APIs, it is typically done on submit. So when you press a button, you typically don't do back-end validation every time you leave a field. And they kind of sound like a lawyer or a police. So they are either as a direct order, they're slightly vague, they can be formal, and they can have very incomprehensible business language in them. The purpose of back-end validation is typically security. We want to protect ourselves from bad data and attacks. It's often very closely connected to business rules. And again, if we catch things in the back end, we will reduce traffic to the database. So we will reduce writing, reading from the database. Drawbacks is that if you don't catch it in the front end, but after the user presses submit. It will kind of break the flow for the user. It's slightly duplication because it both duplicates validations in the front end and validations in the database, if used correctly. And they are often a lot of the generic catch-all messages generate from the backend. Here are things like HTTP responses and similar things that are really good for a tester to know about. Here are some different types of backend messages. We have the vague, the server is unreachable at the moment, which could mean everything. We have the Google 404. They can't find the URL we're looking for. In the white and blue box in the middle, we have another HTTP answer. It's a 500 request response, where the gateway timed out. Or you have these very technical error messages with words like class and properties and things like that. And just a slight disclaimer, front-end errors can also be very, very technical. This could potentially be a pure front-end error. But my experience tells me that it will be phrased slightly differently. And also, they are more likely to be caught and not get all the way to production. This is the GitHub error message, very vague. Oops, something went wrong. Doesn't tell you much. This is the YouTube error message. Sorry, something went wrong. They're helpful, generic. They catch a lot of problems, but they don't really tell you what went wrong. So it's very hard to act on it as a user. But if you see here on YouTube, they have next to the blue reload, there is a details. And if you click on that, you would actually get more information of the problem that you want to hide from the typical user because they will get confused by all of the details. But if you're someone more technical, if you want to send it to YouTube, if you want to send it to a developer, there's a lot of information in that details page. And then we get to the database, or the data storage. Could be another type of data storage, but what I know most about is databases. Database validation happens when you save, update, create, or delete something. So if you try to sign up, it's what comes at the last stage. It's if you update a customer, it's what happens when you try to save the changes. And it kind of sounds like a robot or an alien. There's a lot of really, really deep technical phrasing in the messages that are both easy to recognize if you know what you're looking for, but hard to understand if you don't know about databases, which I encourage all the testers out there to know more about databases because there's so much interesting stuff you can test around databases. The purpose of database validation is to keep our data in a good quality and in a format that we can handle. So data integrity and quality. It is our last line of defense. If it gets all the way into the database, it will be there and it could crash potentially other services that can't handle the data. And again, drawbacks, problems are caught very late. So we've lost so much context from when the user actually inputted some data. So I don't know if the whisper game is something that's available outside of the Nordics, but while the front end knows exactly what the user inputted, what the user tried to do, for every step we take away from the interface, we lose a bit of context, and it's hard to send that information all the way downstream and then all the way upstream again, which means the error messages can be really, really hard to explain to a user. Because even though I know exactly what a unique constraint is, most users don't. So this is a picture from, it's a training site for testing databases and tables. And what I was doing is I was trying to buy a ridiculous amount of snakes and parrots and fish. Let me tell you, I would not want several thousand snakes in my house, even though they were venomless. Everything looked amazing. The front end could handle whatever I threw at it. The front end stopped me from entering ridiculous quantities, even though this is a ridiculous quantity. Even more ridiculous quantities were stopped. I could remove, I could add, but when I tried to check out, I got a data exception problem saying numeric value out of range, table order columns total price, which is a very typical database validation error. And numeric value out of range means it's a number that's too big or too small. And I just assume it's related to the huge subtotal here. So database errors or messages are easy to spot once you see them because they have a very particular language. And you can often get them in like this format. You get a very big blob of text with huge amounts of information. And then somewhere in all of that text, you have words like data, index, constraints, tables, and such. Or if you're incredibly unlucky, you could have the actual database having some sort of issue. So a problem like this with Oracle initiation or shutdown in progress means the database is not online at all. So it's not even the data in the database or the action you're trying to make to the database. The actual database is not up and running, which is usually a big problem. And then, as I mentioned, all of the things like front-end and back-end and database are hopefully things that we can affect because it's hopefully in our team or a team close to us. But there's so much else that our software connects with today. We have Windows as an operating system that might give you all of these extremely strange exceptions where you have to Google the exception name to figure out what it does. You have the SMTP errors from your mail server. You have strange errors like an integrating service, like the worker status here, where you get status success, you get completion as a result, but it also says that it failed to send an email. So this is actually extremely confusing because it's telling you that this was a success, but it was a success in failing to send an email, which is extremely strange. So while this is kind of my generic catch-all, these error messages and messages in general, what is typical about them is that they look strange. They look very, very different to all of the other ones. And they can be related to contracts being broken. So if you have a list of values on your side and then suddenly you see that it's translated into something else, you could have a contract that's been updated on the other end, but not fixed. You can have services on the other side being down because they have different office hours. You can have timeouts. You can have problems with serializing and deserializing information. You can have race conditions, all of these fantastically cool things to test, but very, very confusing and frustrating for a user. And I asked my friend Samuel to send me an example of what it could look like because he's a database developer. And I asked him to send me an example and he sent me this. It's an unexpected error and then there's a huge blob of text. And the thing that tips me out about this being an integration to something else is that, again, we get something that doesn't really look like an error because we get this big XML back instead of what actually went wrong. So we can group these error types into 4 different categories. We have error types that are connected to availability. We have timeouts, we have server is unreachable at the moment, some service that our frontend depends on is not available. We have problems that are related to authentication. So your credits, you're not allowed to do different things. It could be that you're not logged in. It could be that you don't have the right role. These are typically things. It could be that your cookie is broken. Then you get errors like 401 unauthorized, for example. Then there's the giant pile of bad input. Somehow bad data slipped through. It could be someone didn't fill in a mandatory field. It could be the wrong format. It could be duplicates. These typically happen if frontend missed to filter some sort of data, but it gets caught or thrown by the backend or the database. And then we have the amazing pile C of unknown errors because we can't catch everything. And sometimes things we did not expect to breaks. It happens. So it's a category on itself. So with 1 minute to spare, summing this up, front-end validation is closer to the user. You don't have as much traffic, but it's less secure. Backend or API is close to the business. So this typically validation around business rule, and it's only 1 step away from the front end, so it's slightly more clear messages. And also I want to stress this, that all of the other validations could potentially be skipped, but backend validation you need to have. Database is close to the actual data. It's our last line of defense, usually very technical language. And then there's also the rest of the ecosystem to think about with contracts and hardware that could break. So you live in this ecosystem and contracts and hardware breaks, and I urge you to learn more about it. You don't have to be a technical specialist in all of it, but know what your interfaces are. Not all problems are yours, and these can be really, really hard to understand, and they can be hard to do anything about, but at least you can know about them. Every time you ship an error, either downstream or upstream, you lose a bit of the understandability, kind of like the whisper game. And then you need to balance things like, do I want to handle as much specific errors as possible, adding complexity to my code, or do I want to do something generic that reduces the complexity of the code, but it also reduces the helpfulness of the messages? And no one of these parts is enough on their own. You need to have, in the best of worlds, all of them, but at least several of them. Cool, I'm done. Thank you so much. I am going to find, there we go.
Okay. Great. Thank you for that. It seems like you really explained and translated some of these errors into more easily understandable language. So thank you so much for that. We want to go ahead and answer some questions now that the audience might have. So we'll wait a minute just to get those in.
And I'll grab some coffee in the meantime.
Okay. Okay, well, I see a couple, so let's go in the order that we have them. So first, question number 1 that we're seeing is, when building software, how do you decide where to put your validations?
Validations that are around helping the user in the front end, validations that are around our business rule, like is a user allowed to have these type of contracts? Is a user allowed to book this room? Does the user have enough money on his account? Backend, and then validation that is related to the data itself in the database. Because if it enters the database in a crappy format, it can break the database and then the entire application is just broken. But then today, a lot of the business validations has also kind of trickled into the front end, because we can do heavier front ends today since data transfer and network traffic isn't as expensive today. But like my general rule is still to keep front end doing front end stuff, back end doing the business rule stuff, and then the database checking the data. If that answers the question.
Yeah, that makes sense. Thank you. Okay, our second question is, why can't each part of the stack polish the message to the end result and be more user-friendly?
I mean, hypothetically, it can. It's just that it adds a lot of complexity to the code, and it's possibly not worth it all the time. And then often it's not the same teams building the same things. We have teams just working on the front end and teams just doing on the back end. And it's, I mean, there might be different understandings. The front end, I mean, from my opinion, if the front end would translate everything, the front end would get really, really heavy. It would get slow and unnecessarily complex. But I mean, I've seen systems where they try. It typically it becomes better, but not perfect.
Okay, so you're saying it's like it has to be a careful balance between the two.
Yeah, and it's not always worth it. And some problems are just not, I mean, I can't explain to someone who is very non-technical why something in the database breaks. So it's probably better to just tell them one of these oopsie messages.
Okay, great. Well, if anyone else has any more questions, please feel free to send them our way. You can always contact us or Lena directly after. We will finish recording in just a moment, and then we'll be sending that out in the coming days, so look out for that. Thank you so much for joining us today. We appreciate the time, and we'll be in touch again soon.